Okay, students. Now I am going to teach you. Already, all of you know the chapter 2 is going on exponent chapter, and in the previous classes, in the first one concept, I have given an introduction to concept exponent. What do you mean by exponent, and what is index? What do you mean by base? Okay, all of you, and what is the application of the exponent? So here, in this class, I am going to discuss about the types of exponent. Okay, so you see I have written these are the points I am going to discuss regarding the types of exponent. Point 1 is the natural number or a positive integer exponent or positive exponent. Okay, second one, negative exponent or negative integer exponent. Negative integer exponent, or we say negative exponent. Third one is the zero exponent, and fourth one is the rational or fractional exponent. These are the 4 points I am going to discuss. Okay, here. So let us discuss about the first point. I am going to discuss about the natural number or positive integer exponent, or we say positive exponent. Okay, you see, suppose I am going to discuss a to the power 1. A to the power 1. So what do you mean by positive? Natural number. What is natural number are called positive numbers, positive integers. So what do you mean by positive integer exponent or natural number exponent? They say that if the power of the exponent, with a given base are natural numbers or positive integers, then such kind of exponent are said to be natural number exponent or positive integer exponent or positive exponent. Okay, if the power of the exponent with a given base are the natural number or positive integer. Suppose a is one of the base. Okay, if the power of, suppose starting, what is the power of a here? A to the power 1. So it is an exponent whose power is 1. Understand? So if a is the given base and 1 is the power or exponent index, then this is called exponential term. And this is an example of positive exponent or natural number exponent. Understand? So what do you mean by positive exponent? Positive integer exponent. So it is saying the exponent which is obtained by multiplying a, by multiplying 1 by a, how many times? What is the power? 1. 1 indicates power or exponent. How many times will multiply a? Once. So a to the power is obtained when the base, given base a is multiplied by 1. How many times? 1 time, because the power is 1. Understand? Similarly, if I write a to the power 2, if I am writing a to the power 2, a square, we can say. A square is also exponent whose power is 2, index is 2, base is. Similarly, a square is also exponent which is obtained when the base a is multiplied by 1. How many times? 2 times. Because the power of a is 2. So when the given base a is multiplied by 1 2 times, because the base is 2, because the power is 2, exponent is 2, then you shall get the resulting exponent which is called a square, and the power of a is 2. Here power is a natural number, that's why a square is an example of positive integer exponent or natural number exponent or counting number exponent. Understand? Similarly, if you are writing a cube. Similarly, a cube is also exponent. Okay, so which is obtained by multiplying the base a by 1. How many times? What is the power? 3 times. Okay, so a cube is obtained when the base a is multiplied by 1, how many times? 3 times. Similarly, if I write a to the power 5. Similarly, a to the power 5 is an example of positive exponent, or is called an positive exponent or positive integer exponent if when the base a is multiplied by the base a number of times 5 times. 5 times. 1, 2, 3, 4, 5. Okay. Here a to the power 1 is equal to 1 into a. A to the power 1 is an exponent, is a positive exponent which is obtained when the base a is multiplied by 1. How many times? 1 time. Similarly, a square is also a positive exponent when the base a is multiplied by 1 with how many times? 2 times. So a square is equal to 1 into a. This is the what? Expanded method I am writing. A square is written in the form of expanded form. 1 into 1 into 1. Similarly, a cube is equal to 1 into a into a into a. Here, a cube is the exponent which is obtained when the base a is multiplied by 1 by 3 times. Similarly, a5 is a positive exponent which is obtained when the base a is multiplied by 1 5 number of times, 5 times, because the power is 5, exponent is 5. If you understand, so what will be positive exponent? So it is saying if the power exponent, the exponent what? The exponent, if the power of the exponent, the power of exponent, exponential term we can say, are natural number or positive integers, then it is called a positive integer exponent. Is it clear? Understand? Okay. So you see now here, if the power of the exponential term are the positive integer or is a positive integer, then the resulting exponent will be a positive exponent. A to the power 1 is a positive exponent because the power is 1, which is obtained in the form of expansion in the process of multiplication by multiplying the base a by 1. How many times? 1 time. Similarly, a square is the positive exponent which is obtained when the base a is multiplied by 1. How many times? 2 times. Similarly, a cube, the base a has been multiplied with 1 by 3 times. Similarly, a to the power 5, the base a has been multiplied by 1 5 times. Please understand or not? So it is saying if a to the power b, is it clear? Let us see. Okay, generally we can say the exponent a to the power b is a positive exponent. Positive exponent means positive integer exponent if the base, if the power of a to the power b is a natural number or is a positive integer, and the base is a multiplied by 1 b number of times. How many times? B number of times. B number of. Understand or not? We can write a to the power 1 again is equal to a square 1 into a a square is 1 into a into a. Okay. Similarly, I can write also here a to the power 6 is an exponent, positive exponent, when the base a is multiplied by 1 by how many times? 6 times, because the power of the exponent is 6. Here value of b is 6, which is a natural number, so this is an example of positive exponent. Understand or not? Okay. Is it clear? Let me listen again, repeat. If the power of the exponential term are positive integers, then the exponent is called a positive exponent. The exponent where b is a positive exponent, is a positive integer exponent. If the power of where b is a, is a positive integer. The power of b is a positive integer, and the base is multiplied. And the base is multiplied by 1. The base a is multiplied by 1, but b number of times. Okay. For example, a to the power 6 is okay. Here the given base is a is multiplied by 1. How many times? What is the power? 6. So 6 number of times have to multiply. So resulting exponent will be a to the power 6, and this is the definition. We can define a positive exponent when the base a of the exponent is multiplied by even number of by 6 number of times according to the power by 1. Then we shall get the exponent, which is called a to the power 6, which is a positive exponent. Okay. So we can give the so many example of positive exponent. Example, you see a to the power 4, a to the power 9, b to the power 10, 2 to the power 5, 3 to the power 7, 9 to the power 4, etc. are positive exponent. Are positive integer exponent. Are positive integer exponent. The power of the exponent are the natural numbers are positive integer. Okay. This is one of the concept. Then let us see about the negative exponent. Negative integer exponent. What is called negative integer exponent. Negative integer exponent. Suppose I will say a to the power minus 1 now. So if the given base, if the powers are negative integers, then such kind of exponent is called negative exponent. Here power of a is minus 1. Understand? How can you define a to the power minus 1? Here a to the power minus 1 is a negative exponent because the power is minus 1. We can define a to the power minus 1 is a negative exponent which is obtained when the given base a is divided by, instead of multiplied, is divided by how many times? How many times? What is the power? Minus 1. If minus 1, if you remove the sign, it will be what? 1 means how many times? 1 times, which is equal to 1 upon 3. So a to the power minus 1, you see how interesting it is. A to the power minus 1 is equal to 1 by a. It means a to the power minus 1 is equal to 1 by a is a reciprocal, we can say also. It means a to the power minus 1 is a negative exponent, actually is the reciprocal of positive exponents. If you say is called negative exponent. Okay, a to the power minus 1 is equal to 1 by a. 1 by a is the reciprocal of a to the power minus 1. Okay. Similarly, a to the power minus 2. A to the power minus 2 similarly is also a negative exponent because the power is negative integer, which is minus 2. And this a to the power minus 2 can be defined when the base a is divided by 1. How many times? What is the power? Minus 2. If you are discarding the sign, minus sign, it will be 2 times. It means it will be how much? 1 divided by a square. So a to the power minus 1 is equal to 1 divided by a square. Okay. Similarly, a to the power minus 5, if you will write how many times? How many times the a is divided by 1? Sorry, a to the power minus 1 is equal to 1. A to the power minus 5 is a negative exponent which is obtained when the when the base when the 1 is divided by the base a. How many times? 5 times. How many times? 5 times. Look at here. 1, 2, 3, 4 is equal to 1 divided by a to the power 4. How many times? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 times. 5 times. So 1 upon a to the power 5. Okay. It means, so let me again discuss. A to the power minus 1 is a negative exponent which is obtained when okay, 1 is divided by the base. How many times? 1 time. 1 divided by a is 1 upon a. A to the power minus 2 when we divide the base by 1. How many times? 2 times, because the power is minus 2. If discarding the side, negative side, it will be 2. It will be 1 upon a square. 1 divided by a is equal to 1 upon a square. So a to the power minus 2 is equal to 1 upon a square. Similarly, a to the power minus 5 is a negative exponent which is obtained when the base a is divided by 1 by 5 times. You see, 1 divided by a divided by a divided by a divided by a divided by a. 1, 2, 3, 4, 5, which is equal to 1 divided by a to the power 5. Okay, students, you think one thing, observe. A to the power minus 1 is equal to 1 upon a. 1 upon a means a to the power 1. Okay. A to the power minus 2 is equal to 1 upon a square. Power is 2. Understand? So 1 upon a square is the reciprocal of a to the power minus 2. It means the negative exponent can also define as the reciprocal of the positive exponent is called negative exponent. 1 by a is the reciprocal of a to the power minus 1. So it is a positive exponent because it is 1 upon a to the power what? 1 is a positive exponent. So reciprocal of negative exponent, reciprocal of positive exponent is also defined negative exponent. We can write 1 divided by a whole to the power 2. So reciprocal of a to the power minus 2 is 1 upon a whole square. It means the reciprocal of positive exponent is also negative exponent, and vice versa also we can say. Similarly, 1 upon a to the power 5. So reciprocal of a to the power minus 5 is what? 1 upon a to the power 5. So reciprocal of positive exponent is also a negative exponent. Can you define? So a to the power b. So if the power of an exponent a to the power b are negative integers, then it is called a negative integer exponent. It is called a negative integer exponent or negative exponent. And also observing here, the 1 by a is the reciprocal of a to the power minus 1. Reciprocal of negative exponent is positive exponent. Reciprocal of positive exponent is also negative exponent. It means we can observe that we can define also the reciprocal of positive exponent the reciprocal of positive exponent is also called what? Negative exponent. Negative exponent, negative integer exponent. Understand? Is it clear, everybody? Okay. Understand? Let us see. Suppose I am writing a to the power minus 7, 1 upon a to the power 7. So reciprocal of 1 by 7 is equal to what? A to the power minus 7. A to the power minus 9 is equal to 1 upon a to the power 9. Understand? 5 to the power minus 7 is equal to 1 upon 5 to the power 7. You see, 5 to the power minus 7 is a negative exponent which is equal to 1 upon 5 to the power 7. So reciprocal of positive exponent is a negative exponent, or reciprocal of negative exponent is also a positive exponent. Because reciprocal of 5 to the power minus 7, you know, 1 divided by 5 to the power 7. Similarly, okay, 10 to the power minus 10, 1 divided by 10 to the power 10. Understood now? So this is clear about the negative integer exponent. Reciprocal of this is positive exponent. Reciprocal of positive exponent is a negative exponent. Understand? Okay. Let us see. Understand? Negative integer exponent. You see. Okay. One observation you are observing. You see, 5 to the power minus 7 is equal to 1 upon 5 to the power 7. See, it means 5 to the power minus 7 into 5 to the power 7 is equal to 1. If you transpose, then this 5 to the power 7 will come to the numerator. It will be multiplied, okay, according to the rule of transposition. Hence, 5 to the power minus 7, 5 to the power 7 is always 1. To understand also, from this also it is clear. Okay, so a to the power minus m into a to the power plus m must be value 1. Remember, it means from this also you clear that this is one of the point. Note 1, note 2. So you got now a to the power m is equal to 1 upon a to the power m minus m. Reciprocal of positive exponent is a negative exponent. Okay, here note 3, a to the power minus m, 1 divided a to the power m. Is it clear, everybody? This is the conclusion you are getting from the definition of negative exponent. Understand? Once again, is it clear? So first you understood the negative exponent. Suppose I have told you 5 to the power minus 3. 5 to the power minus 3 is a negative exponent. Definition understood. When the base 5, when we divide the base, when we divide the base by when the base 5 is divided this is wrong now. So you see, 1 divided by 5 divided by 5 divided by 5. What you understand here? So when we divide the base, okay, when we dividing, when 1 is divided You can say also other word. Divided by 5 how many times? As how many times? 3 times. Because power is 3. So when the understand? Okay. So when the base divides 1 5 times, we can say also. When the base divides 5, we can say also when base 5 divides 1 how many times? How many times? 3 times. 3 times because the power is 3. So we shall get the exponent which is equal to 5 to the power minus 3. Understand? This is about the negative exponent. Let us see 0 exponent. 0 exponent. Third point. Zero exponent means what? Suppose a to the power 0 is equal to what? 1 into, all of you know one thing, let me clear. According to positive exponent, we studied what? A square is a positive exponent which is obtained when the base is multiplied by a, how many times? 2 times. We shall get x square. Similarly, a to the power 5 is a positive exponent when the base is multiplied by a, how many times? 5 times. Similarly, if I will say a to the power 1 when the base is divided by how many times? 1 time. Similarly, a to the power 0 when the base a is divided by is multiplied when the base a is multiplied by 1 how many times? 0 times. So you get the definition of 0 exponent. So when understand? So a to the power 0 is equal to 1 also. Okay. A to the power 0 means it is a 0 exponent when the base a is multiplied by 1 how many times? Power 0 means 0 times, means a to the power 0 is equal to 1. So this is also you can also prove also a to the power 0 is always 1. Understand? So a to the power 0 is a 0 exponent. If the power of the exponent is 0 with any base, with any given base a, it is called the resulting exponent is called a 0 exponent. Understand? 0 exponent. And the value of the 0 exponent is always 1. I can write the a to the power 0 is equal to 1, which is obtained when the base a is multiplied by 1. How many times? 0 times. Okay? This is obtained. A to the power 0 is obtained is equal to 1. Understand? Remember? This a to the power 0 is equal to 1 means what? A to the power 0 means that when the base a is multiplied by 1, how many times? 0 times. 0 times with what? 0 to 1. So a to the power 0 is equal to 1. Is it clear? Regarding 0 exponent. And also you understood here a to the power 0 is equal to 1. Okay. And if a to the power 0 is equal to 1, so a can be any real number. Understand? So a to the power 0, whatever number you will see, the base, the value of the power is 0, the value is always 1. Understand? Okay, students? Then last one is the fractional exponent. Fourth one is the fractional exponent or rational or fractional exponent. Understand? It is saying, the student, it is saying the power of the exponent is a fraction or rational number. Then the resulting exponent is called a what? Rational or fractional exponent. If the exponent whose power is a rational number or a fraction number, rational or a fraction is called a rational exponent. Rational exponent. Understand? For example, a to the power b by c is a rational exponent. Rational. Yes or no? Is it rational exponent? Because the power of, what is the power? The power is equal to b upon c, which is a rational number. So the exponent is a rational exponent. Understand? Okay. So let us see the exponent whose power is a rational number or a fraction is called a rational exponent. Example, a general form, let a to the power b by c, a to the power b upon c is a rational exponent because power of a is the base, power of a is a b by c is a rational number or a fraction. So it is a rational exponent or fractional exponent. Okay. In this, you see, a to the power b upon c is a rational exponent. We can write here one thing you just do the new terms for you. Let us see here a to the power b upon c. And then c, what is c? C is equal root of the base. Root of the base a. Root of the base a. Root of the base a. This is called root of the exponent or root of the base a. And b is the, okay, and c is the root of the base a. Okay, and raised to the power b. Raised to the power b. Okay, so a to the power b upon c can be written also a to the power b. This is called c, root of c. This is called c root. This is called c root of a to the power b. I can write also a to the power a cube root of c whole to the power b. Understand? Is it clear? Let us see. A to the power b upon c, power b by c. Here the b by c, the c is the denominator of the, is called root of the base, and b is the power of the exponent. Understand? For example, I am telling you one example. I am just showing you. So the 81 to the power 3 upon 2 upon 3 upon 4. 3 upon 4 is an example of what? It is an what? A rational exponent. It is a rational exponent. Because the power of the exponent is also a rational number or a fraction. Okay. And we can write 8 to the power 81 to the power 3 upon 4. How can I write? 81 cube root of 4 whole to the power 3. And cube root of 81 cube root of 4 is equal to 3 to the power 4 cube root of 4 whole to the power 3. So this value you can written also 3 to the power 4 upon 4 whole to the power 3. So 3 to the power 4 can be cancelled. Is equal to how much? 3 to the power 3 is equal to how much? 27. 27. And it means this is called the root. What is the root of this exponent? Root of exponent is 4. What is the power? What is the power? The power is 3 because we have written 81 has been converted into 3 to the power 4. I can write here 81 to the power 3 by 4. I can write 81 cube root of 4 whole power 3. Okay. What is the root of the exponent? It's 4. And this sign, okay. And we can write 81 can written 3 to the power 4. So 3 to the power 4 again 3 to the power 4. We can write 3 to the power 4 upon 4 can be cancelled power 3. So 3 to the power 3 is equal to 3 to the power 1 is equal to 27. Is it clear? Understand? And this sign is known as a radical sign. This sign is known as a radical sign. This sign is known as a radical sign. And this is known as what? This is known as what? 81 is known as radicand. 81 is known as radicand. Ready? And 3 is the power. 4 is the order of the root. Okay? Achha. Let us see another example. Suppose I will write 8 to the power 2 by 3 is also a rational exponent. Another example. How can I write? How can I write? I can write 8. What is the order of the root? Order of the root is 3. Okay. Cube root whole to the power what? 2. I can write. Or I can write also 8 plus square cube root of 3. I can write also. So 8 square how much? 8 square how much? 64. 3. And can you tell what? 64 to the power what? Power is 1. Can you written 1 upon 3 is equal to 4 to the power 3 into 1 upon 3. 3 cancel is equal to 4. Answer. Understand? So 64 can written 4 can written in the form of exponent. 4 to the power 3. 4 to the power 3. 64. So 4 to the power 3 power 3 will be multiplied. Let us see. 4 to the power 3. 4 to the power 1 by 3. So you can multiply 4 into 3 into 1 upon 3. Cancel 4. Hence 8 to the power 2 upon 3 is equal to 4. We can evaluate, but this is an example of rational exponent where 8 is called radicand. 8 is the radicand. Here 8 is called radicand. 8 is called radicand. 8 is called radicand. We can write. Understand? And 3 is the root of the exponent and 2 is the power of the exponent. Which is negative, positive integer. Is it clear to all of you? Understand? So you can write 8 to the power m by n is equal to, in this order, 8 to the power m cube root of n. One conclusion you get also here. Remember, this is another notation of the in the form of with the help of radical symbol. The symbol is known as radical symbol. Radical symbol. This is called radical symbol. So another type of exponent is a radical sign. Understand? So you come across 4 type of exponent. One is the natural exponent, or positive integer exponent, negative integer exponent, zero exponent, and rational exponent. A new term is associated with the rational exponent or fractional exponent. Okay, this class you studied the types of exponent. Okay, thank you students.